Hello everyone, hopefully you're doing well. In this video, we're going to take a look on section 3D index numbers, the CPI and beyond. So we're gonna talk about the consumer price index. The goal for us is to define and explain the purpose of index numbers. We're going to calculate index numbers relative to reference values. We're going to define and understanding the consumer price index, the CPI, and use the CPI to describe effects of inflation. So at some point, what we would do in this unit is investigating the meaning and use of index numbers, focusing especially on the consumer price index, the CPI. So, one of the things you hear very often that index numbers such as the consumer price index, the producer price index, or the consumer confidence index. So index numbers are common because they provide a simple way to compare measurements made at different times or in different places. Now, the indexing, index provides a simple way to compare measurements made at a different times or different places, as we said. So the value at one particular time or places must be chosen as the reference value. So when we talked about this, usually with these tables, you can see in this one here, these tables, um, so the average. Let us an examples we can use to explain. These tables show the average price of gasoline in the United States at 10-year intervals from 1965, all right, to 2015 and in 2020, right? Right, that's what we do in it. So you can look at it like suppose that instead of just looking at this price, we want to find out how each of them compares to the price in 1985, for example. You see, gas price was like only $1.20 in 1985, right? So one way to do this is to express each year's price as a percentage of the 1989 and 85 price, right? So you're gonna just take the price of the year interested to, and you divide it by the price of 1985. So that's what we said. If you divide, for example, let's say if you take the price for hold on, I need to go this one. If we divide, for examples, the price for of 1975, let's say if you have 1975 over 985, I mean we're talking about the price. That means you can take 0.57 over uh 1985, 1.20, right? If you do that, then you'll find the answer would be 0.475 or 47.5%, right? So if you see this price like this, what you can conclude, proceeding similarly, for each of the other years, we can see because this is 47%, right? So we notice that when you divide this, we find that the 1975 price was 47.5% of the 1985 price, right? So there's a significant raise on this. So similarly, for each of the other years, we can calculate all the price as percentages of the 1985 price, So that's why we're gonna use this tables for. So that's, we call it 3D point one, tables. Note that the percentage for 1985 is 100% because we choose the 1985 price as the reference value. So it's 100%, right? Now, if you look at the last column of this table, it is identical to the third column, right? Very identical, except we don't put the percentage sign, right? Except the percent, we drop the percent signs. So this simple change converts each number from a percentage to a price index, which is one type of index numbers. All right. So the statement 1985 equal 100 in the column heading shows that the reference value is the 1985 price, right? In this case, there is no particular advantage to studying the comparison in terms of index numbers rather than percentages. However, we'll see shortly using index numbers is helpful in case where many factors are being considered simultaneously. So we're gonna go with an examples very quick. As we said, for the index numbers, as you can see, you take the value, you divide it by the reference value. For example, because we're interested on the 1975, we take the values of 1975, we divide it by the one, which is our reference, 1985. So that's and we multiply by 100% to make it, when we multiply with 100%, we make it percentage. There is no particular rule for rounding index numbers, but in this book, we will round them to the nearest. All right. So that's mostly what we're gonna do in this one. All right. So now let's go with our first examples, if you don't mind, because we're talking about the index. So what the sorry. What they ask us to do here, use the table 3D1, the one we just showed you in the previous slides, this one right there. So we said use that table to answer the following questions. So the first questions we're gonna they ask us to answer, suppose the current price of gasoline is $2.55. All right. Find the current price index. They ask us to find the current price index, you know, um, for 2 point. Yep, current price index using the 1985 as the reference value, as we said. So in that table, all right, in that table, the table shows that the price index 1985 equal 100, right? We're gonna say to find the index numbers, take the current price. What is the current price? They tell us the current price for A is 2.55, and you divide it by the price of 1985. What is the price of 1985 again? This is the price of 1985 is 1.20. Now, when you divide these two, it gives you 2.125. So remember, you must multiply by 100 to make it into percentages. So at some point, it gives you 212.5%. So the price index is 212, you know. So that's significant if you compare it to 1985. So price index number is 212.5. All right. The percentage sign is dropped, so we can leave it like this. Now, I can go with a second examples very quick. Let's go with B. For B, they said, suppose the current price of gasoline is $2.30, right? The current price index using the 1985. Again, here you can do the same for B. You did 230 over 1.20 That give you 1.917. If you put it into percentages, when you multiply with 100%, with 100, sorry, not percent after that because we just put it in 100 times 100 to put it into percentages. We found this is 191 7%, 0.7%. So the price index number is 100. Price index number is 100 91.7. So remember, we dropped the percentage sign. So I think I do two of these, and you can definitely continue with the other ones because look at C. C is talking about 2015, right? Because for C, they said if it costs $12 to fill a gas tank in 1985, how much would it cost to fill the same gas tank in 2015? So you see 2015 in these tables, right? So the price index in 2015, what is that? You need to find it first. No, look, price index 2015 would be what? 2015, look at 2015, what you see, 2015 is $2.52 over $1.20. Remember, our reference one is always the one we have with reference is always the 1980 85. Okay, so we're gonna have 252. I'm trying to do the operation. 252 divided by 120. So we notice that it is 2.1. If you multiply with 100, it gives you 210. All right, it's 210%. No, yeah, percent. Now, price index number for 2015 is 210, right? So we know the price index for 215 is 210, which means price in 2015 were 210% of the price in 1985. No, $12 gas on 1985 is equivalent, all right? $12 is equivalent to 12 times 200 times 10. When you multiply these two numbers, it is $25.20 in 2015 to fill, okay, a gas tank. So what we mean, if you needed $12 to fill the gas tank in 1985, right? So if you needed to fill a gas tank in 1985 for $12. In 2015, you needed $25, like more than double, right? The price because the price index is 210%. So it's more than double. So I'll leave you this so you can do it on your own, even though we have a few other examples here. In this one, what they ask you to do is use the 3D point three, tables because we have multiple tables. Assume that all prices have risen at the same rate. So I think we need to go through the consumer. Yeah. So at some point, it's very important to do to consumer price index. I believe this, sorry for this, but that's the definition should go before that slide. I think I mix it a little bit in terms of examples. it's very important that we go over these definitions first because we can make comparisons, but now what we can see in the three, before we even do any the next example, sorry, I need to put it right there also. Okay, sorry about that. Let's see if I have the tables. I believe that table right there. Should that be? No, that's not what we're looking for. Okay. But this table also, we can see changing the reference value. So this table, when you change the reference value, there is no particular reason why we choose the 1985 as the reference value, in 3D, because it's exactly the same thing. I don't know why I need to put it there. So this slide is here. I'm sorry that I messed up a little bit the slides, but I'm hoping you understand what we do because after we use that that table, because this is the same table I put here, which is the average gas price. But what we said about this, there is no particular reason why we choose the 1985 price as the reference value in that table. It is easy to recast the table with a different reference value as well. So you can choose any of these. That's what we try to say, that any reference value can be used to calculate an index. But changing the reference value result in different index numbers. So that's why we only go with 1985. We didn't change it. Now, let's talk about something very important also is the consumer price index. So we've seen, sorry about that. I'm sorry. So we've seen so far, all these definitions. I'm gonna just make sure we checked because after that we're gonna do. Let me do all the definitions, then we can focus on exercises because these definitions we've seen that the price of gasoline has risen substantially with time. It's really risen. Look at the previous tables, you would see that the price never goes down. So we started 1965 with 31 cents, then 57 cents in 1975, $1 and 20 cents. So ever since now in 2020, we went the lowest in 2020 for $2.26 at sometimes during COVID time. But between 2010 and 2020, sometimes it went up to $4 anyway. But most of what the price and wages have also risen. A phenomenon we call inflations, right? So inflations is something we have to deal with for all the time. Price and wages occasionally decline with time, which is deflation. We can have inflation, the price risen, deflation, the price drop. So changes in actually price therefore are not very meaningful unless we compare them to the overall rate of inflation, which is measured by the consumer price index. So the consumer price index is computed and report monthly by the U.S. Bureau of Labor Statistics, if we refer to the U.S. Economic system, right? It represents an average of prices for a sample of goods, services, and housing. So the monthly sample consists of more than 60,000 items. The details of the data collect and index calculation are fairly complex, so especially if you use the previous table. But the CPI, the Consumer Price Index itself, is a simple index numbers. So that's why we said we're going to use a different table. Let me put that table here for you because again, that's something I was supposed to think first. But instead of putting it there, I'm gonna make a copy of it and come back and add it here. So this table right here, as you can see it, here we go. Hoping you can read it, all right? So this table, average annual consumer price index, we see that, sorry, that table, average annual consumer price index over 40 years. we do it for 19, over 40 years. That's we do 1981 to 2020 in that table, as you can see. Note that the reference value used for CPI is an average of price during the period of 1982 and 1984, which is why the table says, we put it that way. So at some point, the consumer price index is based on average prices of for a sample of more than 60,000 goods, service, and housing. It is computed and reported monthly. We said that the rate of inflation, because rate of inflation is also important for you to see, um, refers to the relative changes in the CPI from one year to the next. Okay, one year to the next, and we can do that, using the CPI, for example. Um, is certain years, and we have the reference here. So it's the absolute over the true value. So always we're gonna do something like that, the inflation rates, and we would have a lot of time to look through it. Now, what we said in the next slide, because we said this is this one, consumer price index, as we said, we're gonna look at that table. We just show you this table right there. Okay. And this is the adjustments, because price of most commodities tend to rise over times. We can't compare price fairly unless we take into account the increase we would have expect from inflations, right? For examples, in that table right there, at 3D.3, the CPI data tell us that from 1985 to 2015, typical prices rose by a factor. 1985, you can see the CPI for it. All right. Uh, you need to subtract these two first. So what you do, you take the 2015, which is what is it? 2015, 237, and you divide it by, you know, uh, it's the CPI, 237 over 107.6. So that gives you a 2.20. In the language of economics, we say that $1 in 1985 was equivalent to 2 point. Okay. So this is what I mean. I'm looking for my pencil. So, oops. So, pardon me. So we said when we do the adjustments, price in 2015, like 237, the CPI you see, over the CPI for 1985, that gives you 107.6. It gives you 2.20. So in the language of economics, we say that $1 in 1985 was equivalent to 2.20 cents, $2.20 in 2015. So you consider what happened to gasoline price. You understand what it is? All right. So that's what we're gonna do for adjusting price for this one, but we're gonna go over a multiple examples. One of the examples we're gonna cover right now is this one, as I said. We're going to use that table. The reason why I put the table for you is because we don't want to go back and forth and using the tables. Now, this said, in these examples, we're gonna not examples, it's really a real exercise. So we said that if someone need $25,000 to maintain a certain standard of living in 1986, Oh, sorry. So if someone is I mean needed $25,000 in to maintain a certain standard of living in 1986, how much would have been needed to maintain the same standard in 2020? So remember, in this case, like we did with the examples, of 2015 when you do the adjustment. So you need to divide the 2020 CPI by the 1986 CPI. So if we go with A, take the CPI of 2020. So you need to go and identify the CPI for 2020. We are right there. You need to divide it with the CPI of 1986 right there. Okay, so I'm hoping you see it. So this is what's gonna happen. We take the CPI of 2020, 258.8 over 109.6. Now, when we divide these two, because the first thing, as we said, you divide the CPI, the 2020 CPI by the 1986 CPI to find the factor by which prices in 2020 were larger than prices, in 1986. So when you take these two, it gives you a 2.36. So that means prices in 2020. So prices in 2020 is, I mean, where, because we're no longer in 2020, we're about 2.36 times larger than prices in 1986. So, 25, so $25,000 in 1986 is what? Is equivalent to how much money in 2020? All you need to do is take the 25,000 and you multiply it by 2.36. So answer would be 59,033 in 2020. So the $25,000 of in 1986 is equivalent to $59,033 in 2020. So that's an examples we covered about you know the equivalent. So we can go ahead and do another examples probably. Let's say if you go with B, B, it says what was the overall what was the overall increase in price due to inflation as a percentage from 2000 no from 19 due to inflation from 1995 to 2005. So 1995 to 2005, that's the one we're gonna do. We do B. So what they tells us, what was the overall increase in prices due inflation as percentage from 1985 to 2005? So the first thing to do, inflation is the relative change. Remember that inflation, we said that before. Where is it? It's on the slide above. The inflation, so the rate of inflation from one year to the next is usually defined as the relative change in the CPI. So we said that the inflation is the relative change in the CPI. So remember that I'm gonna put it inflation is the relative change. Inflation is the relative change in the CPI. Okay. So this is what we do. Um, we're gonna do remember, we need to subtract the CPI. For us, we do the CPI of 2005 minus the CPI of the previous years, which is 1995. Oh, remember, if we do things relative, is always in percentages. So we're gonna do it also over the 1985 because that's CPI 1985, 1995. So what is the inflations of 2005? Let's go with 2005 first. All right, where is 2005 in this one? 2005 is 195.3 and 85. Do we say 85? 95. 95 is right there. 152.4. All right, let's write it. We have 195.3 minus 152.4 over the one for 95 is 152.4. So when we do this, answer is 0.281, which is 28.1%. Okay, so that is the inflation over the span of 10 years because 1995 to 2005 is 10 years. All right, years. That is, it's not an annual rate actually, it's inflation. So there's a big inflation, 28.1%. So that's how you compute all of this. Remember, we're doing quantitative reasoning. So it's a combination of some statistics. We do some algebra, of course, not a lot of algebra. We do some liberal arts and math for liberal arts students, and we also do I said statistics already, but we do some finance. Okay, very important to see. We're gonna do some finance. We're gonna continue talking, especially about a lot of percentages, rate, taxes, discounts. We're gonna talk about all of this. Well, I hope you use these two examples to do the other four. Let's go with the next exercise. Um, in the next exercise, we talked about the total spending on healthcare in the United States rose, okay, from 253 billions in 1981 to 3.8 trillions in 2019. So it's only like very, very, very quick, like not a lot of years, 2019, about 30 something years, right? Compare the relative change in healthcare spending to the overall rate of inflation as measured by the consumer price index. So that's something we're going to focus on, and it's not going to take a lot of. So healthcare spending, one of the things we're going to see, remember, we need to come. Okay, I don't know how much will you miss from what I was talking about, but these examples, because my computer keep muting me. All right, I'm gonna try to fix the problems, and hopefully moving forward, you're not gonna have it anymore. So in these examples, they ask us to compare the relative change in healthcare spending to overall rate of inflation as measured by the Consumer Price Index. Remember, in this case, for the health care spending. This is, let's see how it's increased. It's increased by, remember, the goal for us is really to do, we need to do the relative. Relative change means we take what happened in 2019 for us is CPI, right? So we take CPI 2019 minus CPI 1981, and we need to divide it by CPI of 1981. So what we do, we take the those numbers are big. So 3.8 times 10 power, we talk about a trillion, that means 12 digits, minus 250. Can we put it in trillions or we're gonna keep it in billion? Times 10 power billions is 9 digits. Over 253 times 10 power 9. So if for some reason you forget how to do those, I strongly advise you to go back and do some computation. So that would give us in total, after you do all these computations, you can use a scientific calculator to do it. You're gonna find 14. Then remember, it's relative change. Relatives mean you need to multiply with 100 to make it um 14,000%. So whatever you find was in decimal. So you know what? I'm gonna write it like this to show you the decimal part of it. So we're gonna have 14,000 if we multiply it with 100, give us 1,400%. See? That's quite a lot. So whereas the overall rate of inflations, uh, if you look at it in different ways, we do when now they said 2019, right? Can we verify that? Because we do uh 19, where's 1981? No, they said total spending on 2 point, all right? But if we see the inflation, because those are the numbers they gave us, right? For the healthcare spending. Now, how about overall rate of inflation? So overall rate of inflations. Well, actually, those are not the CPI. So I need to remove the CPI from this is whatever we have as the health. Those are the health. I'm gonna put health, okay? Healthcare spending. I'm gonna put HC for healthcare spending. But now that's where we're gonna use the CPI because for this one, we're gonna say CPI of 2019 minus CPI of 1981 over CPI of 1981. So we're gonna go in that beautiful table we have. 2019. Can you look for 2019 in this one? It is 255.7. 255.7 minus 1981 is 90.1. 90.9, right? Over 90.9. So what the answer for overall inflations is 1.81, which is when you multiply it by 100%, it gives you 181%. So this is, you see, overall expending in healthcare is 1,400%, but the overall inflation it was only 181%. So that's an examples. As we said, we have plenty of examples like this. Like this one, we only ask you to verify according to the board. If we go according to the board of the College Board. All right, the average tuitions and fees at the private four-year college and universities increases from $8,396 in 1990 to $37,650 for 2020 and 2021 school year for per full-time students, right? Calculate the relative change. Remember, relative change is always percentages in private college cost. All right. So the same. What you need to do, like it's like we did in the previous numbers, you know. So we only need to take the $37,650 and you subtract 8,396 over the expense in private college, which is $8,396. So when you do these divisions, it gives you the relative change in the cost of private college that is 3.48. So there is an increase of 348%. That's a relative change in in the tuition for colleges from 1990 to 2021. But in terms of the consumer price index, the CPI, if we compare for the rate of inflation, so the rate of inflation. Now you need to compare do it for relative change of the CPI. So we take the CPI of 2020 and we subtract the CPI 1990 from it and you divide by CPI of 1990. So what happens here, we need to go back to the tables where identify the CPI of 2020. We see that 2020 is 258.8%, 258.8% for 2020. And you go back again, you check for 1990. 1990 was 130.7. Minus 130.7, you must divide by 130.7. So at some point, the rate of inflation was only 0.98, or if we multiply it, it's 98%. Every time we say the relative change, it must be expressed as percentages. All right, so that's what we do in this example. So we have plenty of examples like this to do, but I'll probably leave you with some of them on your own because for this one, it's exactly the same type of questions. I'm pretty sure you can do it. And let's look at the last exercise at some point. So now, during these examples, where they give us the price of gold, end of year closing price in dollar per troy ounce is shown in this table. So this is the price of gold. 19, we have a lot of these from 19. All right. Um, we said that 1986, okay, 1996, 2006, and 2020. All right. So we have a few years here. The price shown in the table are not adjusted for inflation. Revise the above table to express all prices in terms of 2020. So, but if you want to review them and make them like for 2020, the first thing to do in this table is to compare each of them. So I can have a different tables when I do right? I can do it for 2020. So what I would do, like 1986, if I want to do it for 2020, all I need to go take the 91, I see for 19 90, okay? 1990, and multiply it by the price index I'm find in the table. So remember 2020, if I use the same table, let me just take the table and bring it here. If I use the same table, I'm gonna put it very small here, just so you can see it. So what's 2020? 2020 is 258.8 over 1986, 109.6. So this one here, when you do the computations, is 9,923. So I can put a different price in 2020. If you want, I can just put this one here. That would be 923. And I'll do the same for the other ones. 1996. So we take this 636 and we multiply it the same by 2020, 58.8. Now we need to do it for 1996 on the table. Look for where you see 1996 is 159.9. When you do this computation in your calculator, you'll find, uh, you know, when we do this one in the calculator, we find 609. So we're gonna find 609. That will be for 19, you know, 609. That's for 19. Now let's do it also for 2006. Look in the table for 2006, 201. Oh, sorry. We take the price for 2006 first, so it would be 6, 3. Oh, 639. The other one was not 639, it's 6369. So 369 was 369 for 1996. Okay, my bad. Now we need to multiply with 258. Remember, 2020 doesn't change. And we divide for 2006, 201.6. 2006, 201.6. So when you do these divisions, what you got, again, um, you got 816. So here we're gonna have $816. But even though you try to do this one, answer wouldn't change, it would be the same. So you answer the first questions. The price shown in the table are not just adjust for inflation. Revise the above table to express all prices in terms of 2020. So that's exactly what we do. The question is, if you bought 3 ounces of gold in 1986 and then sold the gold in 1996, would you have seen a profit on the midnight or not profit? When you adjust for inflation, you know, um, adjust for inflation, 609 per ounce is a loss, right? Compared to 923. Okay. So if you compare, look at that. It's a loss for you because adjustment in 1986 is like $923. Now it's dropped to $609. So when adjust for inflation, $606 per ounce is a loss compared to 923. So you don't make a profit. Have you seen profit? No. Like let's say C. if you bought 3 ounces of gold in 2016, I mean 2006, sorry, in 2006, you buy 3 ounces of gold and then sold the gold in 2020, would you have seen a profit? I'm really waiting for you to answer these questions. Yes, when adjust for inflation, you see you jump from $816 to $1,890. So, when adjust for inflation, $1,809 per ounce is a gain. Compare gain. I mean that's a profit. Compare to $816 per ounce in 2016 and in 2006. So hopefully this helped you to complete the assignments. Don't forget, if you have any questions, you know how to reach me. I'm looking forward to see you. Take care.